This is Pre-Calculus, Section 3.6 Notes, Part 2. So I'm continuing to build my table. I'm still plugging my values in. When x is 2, I get negative 1/4. When x is 4, I get 1/6. And when x is 5, I get 2/7. Okay, so now I'm going to go ahead and I'm going to plot these points. When x is negative 5, I'm at 2 and 2/3. Negative 4, I'm at 3 and 1/2. Negative 3, I'm at 6. And basically, I can kind of see what's going on here. We're going to have a branch that looks something like that. Then I cross over my asymptote where I'm undefined at negative 2. At negative 1, I'm down at y equals negative 4. And then I've got my y-intercept. When x is positive 1, I'm at negative 2/3. When x is positive 2, I'm at negative 1/4. Then I have my x-intercept. And then when x is 4, I'm at 1/6, and then 2/7. So I'm creeping up nice and slow towards that asymptote. And there we go. That's a pretty accurate look at what this function looks like graphically. Moving on to the next example, let's try another one. We're going to graph this rational equation. Now this one looks like it has a numerator that can be factored and a denominator that can be factored. In the numerator, we can factor out an x. And in the denominator, that's an easy factor. Two numbers that multiply to make negative 6 and add to make negative 1 are going to be negative 3 and positive 2. Okay, so let's start with our asymptotes here. We know that we have vertical asymptotes where the denominator equals 0. So in this case, the factor x minus 3 will equal 0 when x is 3, and the factor x plus 2 will equal 0 when x is negative 2. Okay, in the horizontal asymptote, the degree of my numerator is equal to the degree of my denominator. So my horizontal asymptote is going to be a ratio of the leading coefficients. And once again, this is 1 over 1. So I'm going to have a horizontal asymptote at y equals 1. My x-intercepts are going to be where my numerator equals 0. So 0 is equal to x times x plus 3. That tells me that I'm going to have an x-intercept at 0, and I'm going to have an x-intercept at negative 3. And then my y-intercept is what I get when I plug in 0 for my x's. So I get 0 times 0 plus 3 over 0 minus 3 and 0 plus 2. But what I end up with here is, in the numerator, I have 0. In the denominator, I have negative 6, which ends up being 0. And obviously, since I have an x-intercept at 0, I have to have a y-intercept at 0. That's the way it works, because that's the point 0, 0. Okay, so I'm going to sketch in my asymptotes quickly. I know I have a vertical asymptote at x equals 3. And I have a vertical asymptote at x equals negative 2. And then I have a horizontal asymptote at y equals 1. Okay, now I'm going to plot my intercepts. I have x-intercepts at 0 and at negative 3. And then I already have my y-intercept plotted. It's at 0. So now I need to go ahead and build a table. I need to choose x values that are on, on all sides of my asymptotes, or excuse me, on all sides of my vertical asymptotes and on, surrounding my x-intercepts as well. So for my table, I'm going to do negative 6, negative 5, negative 4, and then I know at negative 3 I have an intercept, and at negative 2 I have an asymptote. So then I'm going to do negative negative 1.5, and negative 1, just to get a thorough look at what's going on there. And then I already know what's happening at 0 because I have a point there. So I'll jump to 1, 2, 4, 5, and maybe just for giggles, I'll throw on a 6 here. Okay, and so now here's where it's handy to have your calculator ready because typing all these in can be kind of a pain. So I'm just going to give you what these values are. When x is negative 6, we have 1/2. At negative 5, we have 5/12. At negative 4, we have 2/7. At negative 1.5, we have 1. At negative 1, we have 1/2. At 1, negative 2/3. At 2, negative 2.5. At 4, positive 4 and 2/3. At 5, 2 6/7, and at 6, 2 1/4. So now I'm going to go ahead and plot these points. When x is negative 6, I am at positive 1/2. Negative 5, I'm at 5/12. Negative 4, I'm at 2/7. Negative 3, I'm at 0. Negative 1.5, I'm at 1. We'll talk about why it's on the asymptote in a second. At negative 1, I'm at 1/2. I already know where I'm at 0. 0, I'm at 0. 1, I'm at negative 2/3. At 2, I'm at negative 2.5. 3, I have an asymptote. At 4, I'm at positive 4 2/3. At 5, I'm at 2 6/7. And at 6, I'm at 2 1/4. Okay, so looks like I have a branch here. And if I looked at another value there in between negative 2 and negative 3, I would see that it shoots down. And then here I have kind of a snake-like looking thing between these two vertical asymptotes. And then I have a third branch up here in the corner. Okay, so you might be wondering, how come the middle part of the graph crosses the horizontal asymptote? Okay, sometimes that happens. So you might want to make a little note here. Sometimes sections of the graph will cross horizontal asymptotes. But never vertical asymptotes, okay? So it is possible to cross a horizontal asymptote. You will never cross a vertical asymptote, though. The last thing that we need to talk about is rational functions that have slant asymptotes. You were all wondering, why do we need to be able to do polynomial long division? Because of slant asymptotes. Let me explain, okay? So first of all, a slant asymptote exists for functions where the degree of the numerator is, and this is very specific, 1 more than the degree of the denominator, okay? Now remember, if you go back and you look at the earlier part of the notes, remember that when our numerator is greater than our denominator, this means that there is no horizontal asymptote, okay? So if you don't have a horizontal asymptote, it is possible that you could have a slant asymptote if the degree of your numerator is 1 more than the degree of your denominator. So if your polynomial r of x is equal to p of x over q of x, and you do long or synthetic division, depending on which one you're able to do. Remember, you can only do synthetic division if you're dividing by a linear factor. Then r of x is going to be equal to ax plus b plus your remainder. Okay? And so your slant asymptote is going to be equal to the ax plus b part from the long division. I know this is kind of crazy math right here, but it's crazy cool. So that ax plus b, the result of the long division, is going to be the equation for your slant asymptote. Obviously, it's a slant asymptote. It's a diagonal line, so it's going to have a slope and a y-intercept. All right, so our last example, as you can guess, is going to be an example with a slant asymptote. All right, so we see our function. We're going to have a vertical asymptote at x equals -2, because that's what would make our denominator 0. Our x-intercepts are going to be at values that make our numerator 0. Maybe we should take a look and see if this numerator is factorable. I think that it is. See here, two numbers that multiply to make -5 and add to make +4. How about +5 and -1? Okay, so our x-intercepts are values that make our numerator equal to 0. So if we take a look at that, that tells us that our x-intercepts are going to be at -5 and at +1. Our y-intercepts are what we get when we plug in 0 for our x's. So 0 squared plus 4 times 0 minus 5 over 0 plus 2. We end up with -5 over 2, which is y equals -2.5. And then finally, the slant asymptote. Now, we're lucky on this one because we're dividing by a linear factor. Remember that you don't have to do long division. If you're dividing by a linear factor, you can do synthetic division. So, of course, if we can, we will, right? So we're going to do synthetic division. Our numerator is 1 for -5. If we are dividing by x plus 2, remember our k number that goes outside the bar is the solution to the factor. So it's -2. We drop the 1. 2 times 1 is -2. Plus 4 is 2. -2 times 2 is -4. Plus -5 is -9. So our polynomial that we get is 1x plus 2, and then our remainder is -9 over x plus 2. But we don't care about the remainder for slant asymptotes. We just care about this part right here. So our slant asymptote is going to be the line y equals x plus 2. All right, so it's time to graph in some asymptotes. I'm going to do them in green this time. All right, so my vertical asymptote is at -2. That's right here. And then my slant asymptote is going to be the line y equals x plus 2. So a y-intercept of 2, and then a slope of 1 over 1. Okay. So there are my asymptotes. Okay, now it's time to make a table. And again, I can choose anything I want. Oh, sorry, I should probably plot my x and y intercepts. So I've got an x-intercept at -5, and an x-intercept at +1, and I've got a y-intercept at -2.5. So it looks like I'm probably going to have a branch on the left and a branch on the right. To verify that, I'm going to build a quick table. And alakazam, I graphed that so fast I bet you didn't even see it happen. There's our completed graph.